The following is an extensive catalog of the variants and specific unique elements of each variant and/or design stage of the Boeing B-17 Flying Fortress heavy bomber. For a broader article on the history of the B-17, see B-17 Flying Fortress. Boeing Model 299, XB-17. The Boeing 299 was the original bomber design made by Boeing to fulfill a request by the United States Army Air Corps for a bomber capable of carrying 2,000 pounds, 907 kilograms, of bombs 2,000 miles, 3,218 kilometers, at 200 miles per hour, 322 kilometers per hour. In 1935, the Boeing 299 competed with several entries by other companies at an evaluation at Wright Field near Dayton, Ohio, USA. On its flight from Seattle, Washington to Wright Field for the competition, the 299 set a non-stop speed record of 252 miles per hour, 406 kilometers per hour. Though it crashed to its destruction on takeoff during a demonstration, the crash was due to flight crew error, not from any flaw in the airplane. Subsequent implementation of a mandatory checklist by the flight crew prior to takeoff ensured avoidance of the flight crew error. Despite the crash, and more important, its much higher cost per unit, Air Corps leaders were impressed by the 299. Boeing was awarded with a development contract. The aircraft has since been referred to as the XB-17, but the designation is not contemporary or official. Y-1B-17, YB-17. Though still enthusiastic about the Boeing design, the Army Air Corps decided to cut its order for service test YB-17s from 65 to 13 after the crash of the original Model 299. On November 20, 1936, the Army Air Corps changed the source of funding from normal funding to F-1 procurement, and redesignated the plane Y-1B-17 before it even flew. Unlike its predecessor, which had used Pratt & Whitney R-1690 Hornet radial engines, the Y-1B-17 used the Wright R-1820 Cyclone that would become standard on the B-17. Several changes were made in the armament and the crew was reduced from 7 to 6. Most changes were minor, the most notable was switching from double wishbone to single-arm landing gear. On December 7, 1936, 5 days after the first flight of the Y-1B-17, the brakes on the aircraft fused during landing, and it nosed over. Though damage was minimal, the cumulative impact of this event and the crash of the Model 299 triggered a congressional investigation. After the crash, the Army Air Corps was put in notice. Another crash would mean the end of the program. Though they were meant for testing, the commander of Army General Headquarters, Air Force, Major General Frank Andrews, decided to assign 12 Y-1B-17s to the 2nd Bomb Group at Langley Field, Virginia. Andrews reasoned that it was best to develop heavy bombing techniques as quickly as possible. Of the 13 built, 1 was used for stress testing. In 1937, the 12 Y-1B-17s with the 2nd Bombardment Group at Langley Field represented the entire American fleet of heavy bombers. Most of the time spent with the planes entailed eliminating problems with the aircraft. The most important development was the use of a checklist, to be reviewed by the pilot and co-pilot before takeoff. It was hoped that this system would prevent accidents similar to that which led to the loss of the 299. In May 1938, the Y-1B-17s, now redesignated B-17, of the 2nd Bombardment Group, led by the lead plane's navigator Curtis LeMay, took part in a demonstration in which they intercepted the Italian liner Rex. Coming into contact with the liner while it was still 610 miles, 982 kilometers, out at sea, the demonstration was meant to prove the range and navigational superiority of the B-17. It also showed that the bomber would be an effective tool for attacking an invasion force before it could reach the United States. The Navy was furious about Army intrusion into their mission, and forced the War Department to issue an order restricting the Army Air Corps from operating more than 100 miles from the American coast. After 3 years of flight, no serious incidents occurred with the B-17s. In October 1940, they were transferred to the 19th Bombardment Group at March Field. B-17A, Y-1B-17A. The aircraft that became the sole Y-1B-17A was originally ordered as a static test bed. However, when one of the Y-1B-17s survived an inadvertent violent spin during a flight in a thunderhead, Air Corps leaders decided that the plane was exceptionally robust and that there would be no need for static testing. Instead, it was used as a test bed for engine types. After studying a variety of configurations, use of a ventral nacelle mount turbocharger position was settled on for each engine. A successive series of General Electric manufactured turbochargers would equip B-17s as standard items, starting on the first production model, and allowed it to fly higher and faster than the Y-1B-17. When testing was complete, the Y-1B-17A was renamed the B-17A. B-17B. The B-17B, 299M, was the first production model of the B-17 and was essentially a B-17A with a larger rudder, larger flaps, and a redesigned nose and 1,200 HP, 895 kilowatts, R1820-51 engines. The small gun turret in the upper nose blister was replaced with a .30 in, 7.62 mm, machine gun, its barrel run through a flexible ball socket. The separate bombardier's window was replaced with a shorter depth, 10-panel, well-framed glass nose for bomb aiming, used through to the E-series airframes. During Army Air Corps service, its bulged machine gun blisters were replaced with the more aerodynamic flush side windows used through to the B-17D subtype. In the interior of the plane, crew members were rearranged. Many internal systems were revised. Most notable of these was a switch from pneumatic to hydraulic brakes. In October 1942, all planes of the B-17B designation were redesignated RB-17B, R indicating restricted. The RB-17B was used for training, transport, messenger, and liaison duties. It was in effect a designation of obsolescence. The B series made its maiden flight on June 27, 1939. 39 were built in a single production run, but Army Air Corps serial numbers were scattered over several batches. This was because of limited funding. The Army Air Corps could only buy a few B-17Bs at a time. B-17C. The B-17C was a B-17B with a number of improvements, including more powerful R1820-65 engines. To boost crew safety, the waist-mounted gun blisters were replaced with teardrop-shaped sliding panels flush with the fuselage, and the ventral gun blister by a metal housing dubbed a bathtub turret, similar in appearance and general location on the fuselage, to the Bola ventral gondola then being used and introduced on the He-111P model of German medium bomber. Some of the most important additions were self-sealing fuel tanks and defensive armor. With the passage of the Lend-Lease Act in 1941, the Royal Air Force began clamoring for use of the B-17. At that time, the Army Air Corps was suffering from shortages of the B-17, but hesitantly agreed to provide 20 planes to the RAF. Though the Army Air Corps did not consider the B-17C ready for combat, it was desperately needed in Britain. They were modified Boeing production B-17C, given the company designation Model 299T. The modifications were the addition of self-sealing tanks and replacement of the single nose gun with 0.5-inch Brownings. The 20 planes were placed immediately into frontline service as the Fortress Mki. In Britain, the plane performed unremarkably. By 1941 September, 39 sorties had made up 22 missions. Nearly half of the sorties were aborted due to mechanical problems. 8 of the 20 were destroyed by September, half to accidents. Their guns tended to freeze at high altitude and were generally unable to effectively protect the fortresses. Their success as a bomber was also limited, largely because they were unable to hit anything from the altitudes at which they flew. The first C-series flew in July 1940, 38 were built. The 18 remaining after 20 were transferred to the RAF were modified to the configuration used in the B-17D. However, one of these, B-17C 40-2047, crashed while being ferried from Salt Lake City, UT, to Mather Army Air Base, CA, on November 2, 1941. B-17D. Though changes in the design made the Army Air Corps decide that the B-17D was worthy of a new sub-designation, the B-17C and B-17D were very similar. In fact, both were given the same sub-designation, 299H, by Boeing. Several minor changes were made, both internally and externally. Outside, the engines received a set of cowling flaps for better cooling, and the external bomb racks were removed. On the inside, the electrical system was revised, and another crew member added. In the aft dorsal radio compartment room just behind the bomb bay with a flexible mount, and the ventral bathtub turret as well as adding the nose mount, cheek guns for the first time, in a longitudinally staggered mount layout, the starboard cheek gun further forward in relation to the port side ordnance, the guns were doubled, bringing the total armament to 10.30 in, 7.62 mm, and 60.50 in, 12.7 mm, machine guns. The B-17D also featured more extensive armor protection. A total of 42 DS were built, and the 18 remaining B-17CS were also converted to B-17D format. The sole surviving example of this model of the Flying Fortress, originally built in 1940 and nicknamed the OLE Betsy by her original crew, is undergoing restoration at the National Museum of the United States Air Force in Dayton, Ohio. She was later renamed the Swiss by her pilot Frank Kurtz. He later named his daughter, actress Swissy Kurtz, after the bomber. B-17E. The B-17E, 299O, was an extensive redesign of that used in previous models up to the B-17D. The most obvious change was a redesigned vertical stabilizer, originally developed for the Boeing 307 by George S. Scherer. The new fin had a distinctive shape for the time, with the other end of the fuselage retaining the well-framed, 10-panel bombardier's nose glazing from the B-series design. Because experience had shown that the plane would be vulnerable to attack from behind, both a tail gunner's position and powered fully traversable dorsal turret behind the cockpit, each armed with a pair of light barrel Browning and /M 2.50 calories machine guns, were added to the B-17E design. Until this modification, crews had had to devise elaborate maneuvers to deal with a direct attack from behind, including jerking the aircraft laterally, allowing the waist gunners to alternate shots at enemy fighters. The configuration with three-window box would also appear on the B-29, and also adopted by Soviet bombers as late as the Tupolev Tu-16 Badger, and in different form on the B-52. The teardrop-shaped sliding panels of the waist gunners were replaced by larger rectangular windows, directly across the fuselage from each other, for better visibility. In the initial fifth of the production run, the ventral bathtub gun emplacement of the C and D versions was replaced by a remote-sighted Bendix turret, very similar to the unit placed on the B-25B Mitchell medium bomber of the same period, which proved to be a disappointment in usability, resulting in the remaining E-series aircraft being fitted with a Sperry ball turret, to be used for all succeeding B-17 versions. A total of 512 were built, possibly from the July 1940 dated order from the USAC for B-17S being for that specific number of airframes, making the B-17E the first mass-produced version of the B-17. One of these was later converted to the XB-38 Flying Fortress. Since production this size was too large for Boeing alone to handle, it was assisted by the Vega division of Lockheed and Douglas. Boeing also built a new plant, and Douglas added one specifically for production of the B-17. In the middle of 1942, 45 B-17Es were transferred to the RAF, where they served under the designation Fortress IIA. Likely because of the shortcomings of the Fortress I, B-17C, the RAF decided not to use the Fortress IIA as a daylight high-altitude bomber, the role for which it had been designed. Rather, they were transferred to the Coastal Command for anti-submarine patrol. 4 known examples of B-17Es still exist in museums in the 21st century, none of which is currently known to be airworthy. B-17F. The B-17F was an upgrade of the B-17E, although outwardly the types were distinguished only by exchanging the bombardier's 10-panel, well-framed nose glazing that had originated with the B-17B, for a molded one-piece or two-piece plexiglass cone, the two-piece version having a nearly transparent diagonal seam. Late production F-series aircraft received substantially enlarged mounts for the cheek-mounted guns on each side of the nose, offset in their horizontal placing, still with the starboard cheek emplacement further forward, and fully feathering paddle-bladed propellers. Numerous internal changes were made to improve the effectiveness, range, and load capacity of the B-17. However, once placed in combat service, the F-series was found to be tail-heavy. The weight of gunners and ammunition when combat-loaded moved the center of gravity rearward from its design point and forced the constant use of the elevator trim tab, stressing this component. In combat, the B-17F proved almost immediately to have inadequate defensive protection when attacked from the front. Various armament configurations of 2 to 4 flexible guns were utilized in the field, as sometimes cannibalized from damaged B-17's tail gun positions, as one example, but the problem was not adequately addressed until the introduction of a powered, Bendix-designed remotely operated chin turret in the final production blocks of the F-series Fortresses, starting with the last 86 B-17Fs built by Douglas of the 605 B-17F-DL bombers built, from the B-17F-75DL production block directly. Derived from its debut on the YB-40 experimental gunship version. By using a stronger undercarriage, the maximum bomb capacity was increased from 4,200 pounds, 1,900 kilograms, to 8,000 pounds, 3,600 kilograms. Though this modification reduced cruise speed by 70 miles per hour, 110 kilometers per hour, the increase in bomb capacity was a decided advantage. A number of other modifications were made, including reintegrating external bomb racks, but because of its negative impact on both rate of climb and high-altitude flight, the configuration was rarely used and the racks were removed. Range and combat radius were extended with the installation in mid-production of additional fuel cells in the wings. Called Tokyo tanks, 9 self-sealing rubber composition tanks were mounted inside each wing on each side of the joint between the inner and outer wing sections. With an extra 1,080 US gal, 4,100 liters, to the 1,700 US gal, 6,400 liters, available on the first B-17Fs, the Tokyo tanks added approximately 900 miles, 1,400 kilometers, to the bomber's range. 3,405 were built, 2,300 by Boeing, 605 by Douglas, and 500 by Lockheed, Vega. These included the famous Memphis Belle. 19 were transferred to the RAF, where they served with RAF Coastal Command as the Fortress II. 3 examples of the B-17F remain in existence in the 21st century, including the under-restoration Memphis Belle. B-17G. Generally considered the definitive B-17 design, all changes made in the B-17F production run were incorporated into the final version. These included a Bendix remotely operated chin turret, an innovation derived from the unsuccessful YB-40 Escort version, bringing defensive armament to 13.50 caliber, half-inch or 12.7 mm, machine guns, with the starboard cheek machine gun mount moved one window station rearwards and the portside mount placed forward, just behind the bombardier's plexiglass nose edge, as a result of the needed stowage space for the chin turret's starboard interior mounted, upward pivoting control yoke. When not in use. For late production blocks of the G series, a revised tail gun position, referred to as the Cheyenne configuration after the modification center where it was introduced, was devised, in which the guns were mounted in a new turret with reflector sight and much greater field of fire. Some 8,680 were built, and dozens were converted for several different uses. CB-17G. Troop transport version, capable of carrying 64 troops. DB-17G. Drone variant. JB-17G. Engine test bed. MB-17G. Missile launcher. QB-17L. Target drone. QB-17N. Target drone. RB-17G. Reconnaissance variant. SB-17G. Rescue version, later redesignated B-17H. Featured A-1 lifeboat under fuselage. After World War II, armament on the B-17HS was removed. It was reinstated when the Korean War began. TB-17G. Special Duty Training Version. VB-17G. VIP Transport. PB-1. This designation was given to one B-17F and one B-17G. They were used by the U.S. Navy for various test projects. PB-1G. This designation was given to 17 B-17Gs used by U.S. Coast Guard as air-sea rescue aircraft. PB-1W. This designation was given to 31 B-17Gs used by the U.S. Navy as the first airborne early warning aircraft /AWACS. Fortress 3. 85 B-17Gs were transferred to the Royal Air Force, where they received the service name Fortress 3. 3 went to Coastal Command in the Azores fitted with radar before reuse with meteorological squadrons. The rest were operated by 2 squadrons of Bomber Command's No. 100 Group RAF at RAF Sculthorpe from February 1944, where they were used to carry electronic countermeasures to confuse and jam enemy radar in support of bombing missions. These Fortress 3, SD, would carry extensive array of equipment, the Monica tail warning receiver, the Jostle VHF jammer, airborne Grosser air interception jammers, G and Lauren for navigation and an H-2S radar replacing the chin turret. They were also used as decoys during night bombing attacks. They took part in various such operations until the units were disbanded in July 1945. XB-38. The XB-38 was a modification project undertaken primarily by the Vega Division of Lockheed on the 9th B-17E built. Its primary purpose was testing the feasibility of liquid-cooled Allison V-1710-89 engines. It was meant as an improved version of the B-17, and a variant that could be used if the Wright R-1820 engine became scarce. Completing the modifications took less than a year, and the XB-38 made its first flight on May 19, 1943. While it showed a slightly higher top speed, after a few flights it had to be grounded due to a problem with engine manifold joints leaking exhaust. Following the fixing of this problem, testing continued until the 9th flight on June 16, 1943. During this flight, the third, right inboard, engine caught fire, and the crew was forced to bail out. The XB-38 was destroyed and the project cancelled. The gains in modification were minimal and would have been disruptive to production of existing models. Allison engines were also considered to be more badly needed for constructing fighter aircraft. YB-40. Prior to the introduction of the P-51 Mustang, a B-17 escort variant called the YB-40 was introduced. This aircraft differed from the standard B-17 in that a second dorsal turret was installed atop the radio operator's position between the forward dorsal turret and the waist guns, where only a single flexibly mounted Browning M2 gun had been, and the single 0.50 in, 12.7 mm, machine gun at each waist station was replaced by a pair of 0.50 in, 12.7 mm, guns, of basically the same twin-mount design as the tail guns used. In addition, the Bombardier's equipment was replaced with two 0.50 in, 12.7 mm, machine guns in a remotely operated chin turret to augment the existing cheek machine guns, and the bomb bay itself was converted to a magazine. The YB-40 would provide a heavily armed gunship escort capable of accompanying the bombers all the way to the target and back. The aircraft was deemed a failure because it could not keep up with standard B-17Fs once they had dropped bombs. It was withdrawn from service after 14 missions. 26 built, 1 XB-40 prototype, 21 YB-40 pre-production aircraft, 4 TB-40 training aircraft. C-108 Flying Fortress. 4 B-17s were converted to serve as cargo carriers and VIP transports under the designation C-108 Flying Fortress. Many more served in the same roles under the designations CB-17 and VB-17, respectively. The first of them, designated XC-108, was a B-17E partially stripped of military equipment and outfitted with various living accommodations. It served as a VIP transport for General Douglas MacArthur. A similar conversion was made on a B-17F, which was redesignated EC-108. The third plane, designated XC-108A, was made to test the feasibility of converting obsolete bombers to cargo aircraft. B-17E-41-2595 was chosen for the conversion. Based in India, it ferried supplies over the Himalaya to the base for the B-29 Super Fortress in Chengdu, China. It proved a difficult plane to maintain, due to lack of spare parts for the Cyclone engines, and was sent back to the United States, where it was based in Bangor, Maine, and flew a cargo route to Scotland until the end of the war. It was sold to a local dealer for scrap, but the airframe survived, and is currently being restored in Illinois. The final one was built under the designation XC-108B, and was used as a tanker to transport fuel from India to Chengdu. F-9 Flying Fortress. Several B-17s were converted to long-range photographic reconnaissance aircraft, designated F-9 Flying Fortress. The F here stands for photorecon and must not be confused with F-4 fighter, which was not introduced by the USAF until after the war. The first F-9 aircraft were 16 B-17Fs, with bombing equipment replaced by photographic equipment. Some of the defensive armament was kept. An uncertain number more were converted to a similar configuration to the F-9, but differed in minor details of their cameras, and received the designation F-9A. Some of these, along with more B-17Fs, received further camera alterations and became the F-9B. The last variant designation was the F-9C, which was given to 10 B-17G, converted in a similar fashion to the previous planes. Those surviving in 1948 were at first redesignated RB-17G, R indicating reconnaissance. FB-17. Post-war redesignation of all F-9 photo reconnaissance aircraft. BQ-7 Aphrodite. Late in World War II, at least 25 B-17s were fitted with radio controls to be used as drones designated BQ-7 missiles, constructed under the auspices of Operation Aphrodite. Loaded with up to 20,000 pounds, 9,070 kilograms, of Torpex high explosive and enough fuel for a range of 350 miles, 563 kilometers, they were used to attack U-boat pens, V-1 missile sites, and other bomb-resistant fortifications. The BQ-7S would be taken aloft by 2 volunteer crew members, who would take it up to 2,000 feet, 610 m, point it toward the target, and transfer control to another B-17. They would then bail out through the open cockpit while still safely over England. The controlling B-17 would follow the BQ-7, and lock its controls into a collision course with its target, then turn around to escape. Because remote control hardware available at the time was insufficient for the task, Operation Aphrodite was riddled with problems. Between August 1944 and January 1945, 15 BQ-7 were launched against Germany, none ever hit its target, and several crew were killed in various parachuting accidents. One bomber left a 100 feet, 30 m, crater in British soil and another circled an English port out of control. It was cancelled in early 1945. PB-1 and PB-1W. The U.S. Navy, USN, received 48 B-17s towards the end of World War II, renamed PB-1 and used for maritime patrol missions. Post-war, the USN acquired 31 more B-17Gs, renamed PB-1W, and fitted with AN/APS-20 radar for airborne early warning equipment and procedure development. The Naval Air Material Center's Naval Aircraft Modification Unit, NAMU, at Johnsville, Pennsylvania modified the B-17S to PB-1W specification by sealing up the bomb bay doors and installing 300-gallon drop tanks on each wing, in addition to the Tokyo tanks mounted in the outer wings, holding a total of 3,400 gallons of fuel, giving the PB-1W an endurance of 22+ hours. Initially PB-1Ws retained the natural metal finish with a protective wax coat, but later the PB-1Ws were painted gloss navy blue overall. The scanner for the 1 MW AN/APS-20 Cs-Arch S-band radio detection and ranging, radar, manufactured by Hazeltine Corporation / General Electric, was ventrally mounted in a bulbous housing below the redundant bomb bay, with the radar relay transmitter, identification friend or foe, IFF, radio direction finder, RDF, instrument landing system, ILS, and long-range navigation, LORAN, also being installed during conversion. The conversion introduced the following changes. Chin turret removed. Norden bomb sight removed. Bombardier's station retained as a lookout post, while on ASW or Airborne Search and Rescue, SAR, missions. Top forward turret removed. Cockpit armor removed. 300 US gallon drop tanks fitted under the outer wings. Extra fuel tanks in the outer wings, Tokyo tanks. AN/APS-20 Cease S-band radio detection and ranging, radar, with transmitter in the fuselage and aerial in a bulbous dielectric fairing under the former bomb bay. Modernized identification, friend or foe, IFF. Radio direction finder, RDF. Instrument landing system, ILS. Long-range navigation, LORAN. 2 radar consoles facing aft in the former bomb bay. Radio operator's seat turned to face outboard. Waist gun positions and ball turret removed. Bench seats fitted for observers at the waist positions. Floating smoke markers carried. A latrine and a galley were fitted amidships. Tail guns and armor removed. Provision for spares and/or cargo to be carried in the tail section. The crew for USN PB-1WS consisted of 6 officers, pilot in command, second in command, navigator, CIC officer, and 2 radar operators/controllers, and 5 enlisted men, plane captain, now referred to as crew chief, second mechanic, electronics technician, and 2 radio operators. First delivered to Patrol Bomber Squadron 101, VPB-101, in the spring of 1946, the Navy was eventually to have 22, out of 31 post-war B-17s, fully upgraded to PB-1W standard. Late in 1946, VPB-101 would move to NAS Quonset Point, Rhode Island, and be redesignated Airborne Early Warning Development Squadron 4, VX4. SB-17G and PB-1G. From 1943 to 1948, as part of Dumbo missions, 12 B-17Gs were converted to B-17HS equipped with an airborne lifeboat and ASV radar for USAF air sea rescue duties. The U.S. Coast Guard flew 17 similar aircraft as PB-1Gs.
Please subscribe and thanks for watching.